Different science exhibit different science cultures and practices. For example, in astronomy, observation until what is today called the new astronomy had always been limited to what could be seen within the limits of optical light. Indeed, until early modernity, the limits to optical light were also limits to what humans could themselves see within their limited and relatively perceptual spectrum of human vision. With early modernity and the invention of lens optical instrument telescopes, astronomers could begin to observe phenomena never seen before. Magnific- Magnification and resolution began to allow what was previously imperceptible to be perceived, but within the familiar limits of optical vision. Galileo have learned of the Dutch invention of a telescope by Hans Lippershey, went on to build some hundred of his own, improving from the Dutch 3x to nearly 30x telescopes, which turned out to be limit of magnificational power without chromatic distortion. And it was with his own telescope that he made the observations launching early modern astronomy, phases of Venus, satellites of Jupiter. Isaac Newton, on the other hand, later improved with reflecting telescopes, expanded upon the magnificational resolution capacity of optical observation. And from Newton to the 20th century, improvement continued on to the latter, very large array of light telescopes today, following the usual technological trajectory of more is better, but still remaining within the limits of the light spectrum. Today, astronomy has now had the benefit of some 4 centuries of optical telescoping. The new astronomy, however, opens the full electromagnetic spectrum to observation, beginning with the accidental discovery of radio astronomy early in the 20th century and leading today to a diverse variety of EMS telescope, which can explore the range from gamma to radio waves. Thus, astronomy now outfitted with new instruments, some smart adaptive optics, very large arrays, illustrates one style of instrumentally embodied science. Techno science, of course, astronomy, with the very recent explosion of probes to solar system bodies, moons, Mars, Venus, asteroids, remains largely a receptive science, dependent upon instrumentation which can detect and receive emissions. Contemporary biology displays a quite different instrument array, and according to Evelyn Fox-Keller, also a different scientific culture. She cites her own experience coming from the mathematical physics into microbiology and takes accounts of the distinctive instrumental culture in her making sense of life. But particularly with the development of biotechnology, instrumentation is far more interventional than an astronomy case. Microscopic instrumentation can and often is intervention in style. Gene splicing and other techniques of biotechnology, while still in their infancy, are clearly part of interventional trajectory of biological instrumentation. Yet in both disciplines, the science involved are today highly instrumentalized and could not progress successfully without constant improvement upon a respective instrumental trajectory. So, minimalistically, one may conclude that the science and technology is instrumentally embodied, but the styles of embodiment differ, and perhaps the last of the scientific disciplines to move into such technological embodiment is mathematics, which only contemporarily has to come to rely more and more upon computational machinery now in common use.